Hello, this is Dr. Dhanashree Patil, a research student, Department of Botany, Shivaji University, Kolhapur. I am here to present my research work entitled Biotechnological Strategies for Phytoremediation of the Azodyes, Reactive Turkish Blue H5G, and Reactive Red M5B using Solanum virginianum. There are many textile industries in our country which pollute the water bodies with the dyes in the effluent released. A majority of these dyes are carcinogenic and mutagenic to the flora and fauna. Uh, Dye-containing effluent have high chemical oxygen demand, biological oxygen demand, and hence to overcome this problem, there are many conventional physical and chemical treatment methods. But these methods are not only expensive, but there are chances that they may produce secondary pollutants. Hence, an alternative method of decontamination is the need of an hour. Phytoremediation is a cost-effective, eco-friendly green technology to overcome this problem. Solanum virginianum, a plant belonging to family Solanaceae. It is one of the 10 constituents of Dashamula of Ayurveda. The plant has immense capacity to uptake the harmful pollutants and degrade them to non-toxic products by using its enzymatic reactions. These are materials and methods. Result and discussion. In vitro seed germination was carried out on the media that is half strength MS medium. The raised plantlets were further used for shoot multiplication, and the media was used here is MS plus BAP. Three different concentration of BAP were used, out of which 0.75 mg per liter showed highest shoot multiplication, and these are the results of shoot multiplication. Further, decolorization of RTBH5G and RRM5B dye was carried out. Percent decolorization was calculated by using the formula percent decolorization is equals to initial absorbance minus final absorbance divided by initial absorbance into 100. The percent decolorization for reactive turquoise blue H5G was carried out with with 8 different concentration of the dye, that is 10 mg per liter to 150 mg per liter, and a biotic control was maintained, which was devoid of dye, and it took 6 to 21 days to show maximum decolorization, and these are the results of RTBH5G dye decolorization. Similar procedure was followed for decolorization of reactive red M5B, and these are the results of RRM5B dye decolorization. Further, enzymatic studies were carried out in order to insight into decolorization mechanism. Activities of different oxidoreductive and antioxidative enzymes were monitored during decolorization experiment. Enzymatic study was studied for both biotic control as well as the plants treated with the dyes, and 8 different enzymes were studied, that is tyrosinase, lactase, lignin peroxidase, catalase, SOD, azoreductase, and NADH DCIP reductase, and these are the results for biotic control. These are the results showing enzymatic activity of Solanum virginianum treated with RTBH5G dye. And here we can see that as the concentration of the dye increases, the induction of the enzyme also increases. Here we can see that peroxidase, catalase, SOD, azoreductase, and NADH DCIP reductase showed highest results than that of the biotic control. Whereas these are the results, whereas in case of RRM5B dye, as the concentration of the dye increases, induction of the enzyme increases, and peroxidase, catalase, azoreductase, and NADH DCIP reductase showed highest results than that of the biotic control. So here we can see that though the enzymatic activity is more or less than that of the biotic control, but still it has maintained its enzymatic status to degrade the harmful dyes. Further HPLC analysis was carried out, and this is the chromatogram representing RTBH5G dye before and after degradation. And here we can see that the sample showed peak at 2 minutes of retention time, whereas the degraded product showed peak at 2.2 minutes of retention time. Similarly, when we see the chromatogram of RRM5B dye before and after degradation, here the sample showed peak at 2.2 minutes of retention time, and the degraded product showed peak at 2.7 minutes of retention time. So here clearly we can see that disappearing of sample peak and appearance of new peak, which proves degradation. Further, a phytotoxicity study was carried out with the help of Vigna radiata seeds. A control was maintained where the seeds were watered with plain water. Then one set was carried out where the seeds were watered with the dye, and the other set was carried out where the seeds were watered with the metabolites of the after decolorization. Here we can see that the seeds which were watered with RTBH5G dye showed very poor growth, whereas the seeds which were watered with degraded metabolites after decolorization showed good results, as good as the control. Similar results were seen for RRM5B dye. Hence, it has been proved that the plant Solanum virginianum has potential to degrade the dyes and survive in the stressful condition. Thank you.